Hi students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Soorya, your chemistry faculty from Infinity Learn. So here in this session we are going to discuss about the complete revision of the chemical bonding chapter. We have already completed the chemical bonding chapter, right? So here we will be revising the complete chapter by using some of the questions which we have expected in the examination point of view. So we will be start from our first question, no need of any more discussion here. So here is our first question. So what will be the answer for this question? Read the question carefully. Which one of the following correctly explains why noble gases rarely form chemical bonds? So options are already provided here. Just read the question, just read the options one by one, then you will get a proper idea. So as we already know, whenever we are discussing about the chemical bonds, these chemical bonds are formed by the part of stability, right? If any of the compounds, if they want the octet or if you want to complete the octet, they will be undergoing the chemical bond formation, right? But in the case of noble gases, they have already completed. They have already have the stable electronic configuration, right? They have already the stable electronic configuration. For example, if you are taking about the case of neon, it will be having 1s2, 2s2, 2p6, which means that complete octet is full here, right? Octet is full here, so that is why they are not forming any chemical bonds here. So what will be our correct answer? Option C will be the correct answer. They already have stable electronic configuration. Now we are moving to our second question. The molecule which violates the octet rule due to an incomplete octet is. The molecule which violates the octet rule due to incomplete octet is. Options are provided here: CH4, BF3, CO2 and NH3. So option B will be the correct answer, right? When you are discussing about the shape of these molecule, BF3, as we already know, will be forming 6 electrons, right? Which means they are incomplete octet. Clear? So option B will be the correct answer. BF3 will be the example for the incomplete octet here. So while discussing about the limitations of the Lewis rule or the Lewis octet rule, we have already studied whether it is forming the incomplete octet or expanded octet and so on. So here is the answer for the question, option B, BF3. They will be forming the incomplete octet here. Now we are moving to our next question. Which molecule's Lewis structure has a central atom with 1 lone pair and 3 bonding pairs? We know how to draw the Lewis structures of any of the molecule. I have already given an idea to draw the structure of the Lewis structures, right? Draw the Lewis structure of any of the compound. So based on that idea, you need to answer the question which one of the molecule will be having the central atom with 1 lone pair and 3 bond pairs. So these are the Lewis structures of 4 compounds given here, right? So from the formula, from the structure of this compound, you can identify that the one which is having the central atom having 1 lone pair. Here it is 1 lone pair and 3 bond pairs with nitrogen and hydrogen, right? So bond pair is equal to 3, which means that option B will be the correct answer. Ammonia is the correct answer here. So this is about the Lewis structure of all the given compounds here. I hope you understand. Now we are moving to our next question. Which of the following compounds has a Lewis structure with a triple bond? Which of the following compounds will be having the Lewis structure with a triple bond? So as we already know about the structure of CH4 and H2, they are forming single bonds only. And in the case of carbon dioxide also, we know that there will be double bond present, right? So if you are discussing about the shape of these molecule HCN, right? This will be the structure. There will be a lone pair present in the case of nitrogen, right? So this is the structure of structure of cyanide compound HCN here. This is a one which is having the triple bond here. So option B will be the correct answer here, HCl. Now we are moving to the next question. What is the Lewis structure of ammonium ion, NH4 plus? Options are provided here, whether they are containing lone pairs, whether they are containing bond pairs or not. So this will be the shape of NH4 plus, right? NH4 plus. So nitrogen with single bonds to hydrogen, and there is no lone pairs present here. So what will be the shape here? Shape will be tetrahedral, right? NH4 plus. Try to draw the structure of NH4 plus. You can identify that there is no any bond pair. I mean, there is no any lone pairs. They have 4 bond pairs with the nitrogen, right? So answer will be nitrogen with 4 single bonds to hydrogen and no lone pair. So option B is the correct answer here. Now we are moving to the next question. The electrovalent bond is also called. So while discussing about the chemical bonds, we have already studied there will be ionic bond as well as the covalent bond, right? So in the case of covalent bond, we have discussed polar bond as well as the non-polar bond. So based on that idea, you need to give the answer for the question. Which one is the electrovalent bond? Whether it is polar bond, non-polar bond, metallic bond or the dipole bond. So these are polar bond, right? Electrovalent bond means polar bond. For example, if you are taking the HCl, right? HCl means there will be the electronegativity difference between the atoms, right? So in the case of chlorine, chlorine will be having more electronegativity. So you will be attracting more shared pair of electrons towards the chlorine. So they will be getting a delta negative charge, polarity, right? Delta negative charge, and for hydrogen it will be delta positive charge. So there will be forming a polarity over here. That is why this electrovalent bond or the ionic bond is again known as the polar bond, right? I hope you understand. So option A is the correct answer here. Now we are moving to the next question. Which molecule is non-polar covalent? We have already studied in terms of covalent bonds. They are formed by the sharing of electrons, right? So in the case of covalent bonds, there will be 2 types of covalent bonds that are forming. One is the polar covalent bond and another one is the non-polar covalent bond. So first we need to identify which one is forming the non-polar covalent bond here. Yes, option C is the right answer, right? So option C means chlorine. So if the covalent bond is formed between same type of atoms, for example, in the case of chlorine, what is they are forming? Chlorine and chlorine, there is no any electronegativity difference between these 2 atoms, right? So there is no any polarity formed. Because electronegativity difference is 0, right? So option C, chlorine will be the correct answer. If you are taking about the case of HF, NH3 and water molecule, because of the electronegativity difference between these atoms, they will be experiencing a polarity over there. So that's why they are forming the polar bonds. Now we will be moving to the next question. Who proposed the electron dot symbols? So this is about the basics of octet rule, right? In the case of octet rule, we will be expressing all the atoms in terms of their electron dot symbols. So these are first proposed by Lewis. So answer will be C over here. Here is the next question. Which of the following is not an example of an ionic compound? So as we already know, the ionic compounds are formed by the ionic bonds, by the transfer of electrons, so that they are forming cations as well as anions, right? And especially these are formed by metal and non-metals. So what about the answer here? As we already know, in the case of sodium chloride, calcium chloride, calcium chloride and sodium oxide, they are forming by the transfer of electrons, they are forming the ionic compounds. But in the case of carbon tetrachloride means CCl4, right? Carbon have the tendency to form 4 valency tendency to share 4 electrons, right? So they are forming the covalent compound here. So correct answer will be option C, carbon tetrachloride, CCl4. While discussing about the shape, I have already mentioned, right? Carbon will be sharing all the 4 electrons with the 4 chlorine atoms here. So they will be forming the covalent compound. Here is the next question. Question is based on the properties of ionic compounds. Ionic compounds in the solid state do not conduct electricity. Which of the following is the correct reason for it? Ionic compounds in the solid state do not conduct electricity. While discussing about the properties of ionic compound, we have already studied they are not the conductors of electricity in the solid state, but in the aqueous state or the molten state they will be conducting electricity. What will be the reason behind that? That is our question. Yes, option A is the correct answer, right? The movement of ions in the solid is not possible due to their rigid structure. But if you are forming their molten state or the aqueous solution, there will be free movement of ions happening, right? Free movement of ions happening. So that is why they are forming, or they are the conductors of electricity in the aqueous state or the molten state. So here is the answer, option A. Now the question is based on the bond parameters. We have already studied bond parameters in terms of bond length, bond order, bond angle, as well as the bond strength, right? So here is the question. Which of the following statements about bond length is correct? Read the question carefully. We have already studied about the term of bond length, right? How bond length is formed, how they are connected to each other with the bond order as well as the bond strength. Read the options one by one. Then you will get a proper idea. So as we already know, bond length is the distance, right? So it will be the distance between the nuclei of two bonded atoms. For example, if you are taking any of the atoms A and B over here, right? There will be nucleus present. The distance between the nuclei of two atoms is known as the bond length. So option A will be the correct answer here. Now here is the next question based on the bond parameters again. Which of the following is true regarding bond order and bond length? How bond order and bond length are connected to each other, whether they are directly proportional or inversely proportional. Here again option A will be the correct answer, right? As bond order increases, bond length decreases. So while discussing about the bond parameters, I have already given bond order is directly proportional to, bond order is inversely proportional to bond length, right? But these are directly proportional to bond strength as well as bond enthalpy. So what is the exact meaning of bond order? Bond order means it is a number of bonds formed between two atoms in a molecule. For example, if I am taking the nitrogen molecule, right? If I am taking the nitrogen molecule, it will be forming 3 bonds in between 2 nitrogen atoms. So what is the bond order here? Bond order is equal to 3 here, right? So if I compare the bond length of this nitrogen molecule, it will be, I have no idea about the proper value of the bond length here. If you are comparing the bond length, it will be less, right? Then if I am taking the oxygen molecule, it will be O, double bond O, which means bond order is equal to 2 here. Then what about the case of fluorine? Fluorine is forming single bond between 2 fluorine atoms, so bond order is equal to 1. So as according to our relation between bond order and bond length, we can say that if I am taking the bond length, I mean if I am taking the order of bond length, right? Which one will be having more bond length? The one which is having very less bond order, right? So F2 will be maximum, then O2, then N2. So this will be the order for the bond length according to bond order. So this is the question, this is the application of the relation between bond parameters given here. Now you are moving to the next question. 3 statements are given here. The bond angle is expressed in degrees. And the statement B is given bond dissociation energy or bond energy is expressed in kilojoule per mole. And statement C is given the bond lengths are measured by the spectroscopic X-ray diffraction methods. We need to identify whether all the statements are correct or wrong, right? So if I am asking about the first term statement, I mean bond angle is always expressed in terms of degrees. So this is true. Then what about the case of bond enthalpy? This is again true, expressed in terms of kilojoule per mole. And last one, while discussing about the bond length, I have mentioned that they will be measured by using the spectroscopy method like electron diffraction as well as the X-ray diffraction method. So this is again true, which means that all the given statements A, B and C are correct. Here we are moving to our next question. What is the bond angle of NH in the ammonia, which means the nitrogen, hydrogen and hydrogen bond angle in the case of ammonia molecule. So if you are drawing the structure, right, this is the hydrogen here and there will be one lone pair is present, right, one lone pair is present here. So as we are taking about the case of these hybridization, we will be expecting the hybridization will be sp3 hybridization. So we are expecting the shape as tetrahedral, right, expected shape is tetrahedral. But because of the presence of one lone pair, what is happening here? Tetrahedral will be having the bond angle of 109 degree or 109.5 degree. But here, because of the presence of this lone pair, hybridization will be same over here, sp3, but the shape will be reduced to pyramidal, right? Then again for pyramidal shape, bond angle is reduced to 107 degree. So what will be our answer? Option C is the correct answer. 107 degree is the bond angle of NH, right? So this will be the 107 degree in case of ammonia molecule. Here is the next question. Bond order is a measure of the number of chemical bonds between two atoms. The reason is given here. A higher bond order indicates stronger bonding between two atoms. Read the question carefully. We need to identify whether the assertion or reason are true or false and if it is the correct explanation or not. So assertion is given here. The bond order is a measure of the number of chemical bonds formed between two atoms. As we already know, right? We have already discussed in terms of the nitrogen, fluorine and oxygen. So in the case of nitrogen, it will be 3. In the case of oxygen, it will be 2. And in the case of fluorine, it will be equal to 1, right? So the bond order is a measure of the number of chemical bonds between the two atoms. That will be true again. Then higher the bond order indicates strong bond between two atoms, which means that bond order is directly proportional to the bond strength. That we can explain in terms of the carbon compounds, right? If we are taking in terms of C triple bond C, that will be more stronger than C double bond C than the C single bond C, right? So what will be our correct answer? Option A is the correct answer. Both A and R are correct and R is the correct explanation of A. Here is our next question. Among the following, the molecule with bond order 1 is. Very easy question we have already discussed in terms of the bond order. 4 different molecules are given here. One is hydrogen molecule, oxygen molecule, nitrogen molecule and helium molecule. Bond order is equal to 1 means there will be forming only single bond between two atoms given here. Yes, option A is the correct answer, right? Option A means hydrogen molecule. They will be forming a single bonds here. So bond order is equal to 1 here. Then what about the case of oxygen molecule? Or double bond or bond order is equal to 2 here. Then what about the case of nitrogen? It will be N triple bond N, which means bond order is equal to 3 here. Now whenever we are discussing in terms of the, in the case of grade 11 class, we will be discussing about the chemical bonding in detail. In that term, you will be going to discuss about the molecular orbital theory, right? Molecular orbital theory. So as a part of the molecular orbital theory, you will be get to know why helium molecule is not existing, right? So in the case of helium molecule, bond order is equal to 0. The exact explanation for the bond order is equal to 0 will be explained in terms of the molecular orbital theory. Or here you can just remember like that helium does not exist as a diatomic molecule. So that's why their bond order will be 0 here. So molecular orbital theory. So what about our correct answer here? Option A is the correct answer. That is hydrogen molecule will be having bond order is equal to 1 here. Now we are moving to the next question. What is the bond angle of hydrogen, oxygen and hydrogen in the case of water molecule? Again, these are the exceptional case of the sp3 hybridization. So just draw the structure of water molecule. Oxygen is a central atom. 2 hydrogen atoms are present. 2 bond pairs are present in the case of hydrogen atoms. And 2 lone pairs are present, right? 2 lone pairs are present. So because of the presence of hybridization will be sp3 itself. So expected shape will be tetrahedral, right? Expected shape is tetrahedral. But because of the presence of these 2 lone pairs, shape will be changes to bend shape or V shape with bond angle 104.5 degree. In general, tetrahedral angle is 109.5 degree. Because of the presence of these lone pairs, the bond angle will be reduced to 104.5 degree in the case of water molecule, and the shape is bend instead of tetrahedral. So what will be our correct answer? Option C is the correct answer, 104.5 degree. Here is the next question. We need to match the column here. From the first set, they have given the covalent compounds, polar covalent compound, non-polar covalent compound. Set B, they have given the properties as well as the example given here. So what will be our correct answer? Covalent compounds are soluble in benzene, right? As we already know, covalent compounds are the polar, right? So they will be forming the like dissolves like. So covalent compounds will be soluble in benzene. So A will goes with 3. And what about the case of polar covalent bond? Polar covalent bond means they will be having electronegativity difference. So B will goes with 1. Then what about this last one? Non-polar covalent bond means they will be forming hydrogen molecule. So C will goes with 2. So A3, B1, C2, which means option A will be the correct answer here. Here is our next question. In which of the following molecules is the bond angle closest to 109.5 degree? Indirectly, they are asking about which one of the following will be having the shape of tetrahedral or the geometry of tetrahedral. So read the question carefully. Among all the molecules, here all the molecules, they are sp3 hybridization. Some exceptional cases are there. And the case of carbon dioxide, it will be sp hybridization, right? So which one will be having the bond angle close to 109.5 degree? That will be our CH4 molecule, right? Yes, option C is the correct answer, CH4 molecule. This will be the shape. sp3 hybridization. Tetrahedral. 109.5 degrees is the bond angle. Then if I am asking about the case of carbon dioxide molecule, it will be C double bond O, sp hybridization. Bond angle is equal to 180 degree. Then shape is equal to linear. Here is our next question. According to the postulates of the valence bond theory, a covalent bond is formed by which process? Whether it is formed with the transfer of electrons or sharing of electrons or the overlapping of orbitals. So valence bond theory means it is simply the overlapping of atomic orbitals, right? Overlapping of atomic orbitals. So which will be the correct answer? Option C, right? Yes, option C is the correct answer. The overlapping of atomic orbitals of two atoms. So you can explain sigma bond as well as the pi bond, whether it is formed by the lateral overlapping or the sidewise overlapping. Here is our last question. Which molecule contains both sigma and pi bonds? Both sigma and pi bonds. So in the case of valence bond theory, we have already studied these bonds are formed by the overlapping of atomic orbitals. So depending upon the overlapping, they will be forming sigma bonds as well as the pi bonds, right? In the case of sigma bonds, they are formed by the axial overlapping or head-on overlapping. In the case of pi bonds, they are formed by the lateral overlapping or the sidewise overlapping. So here, in the given molecules, we need to identify which molecule contains both sigma and pi bonds. So we need to just draw the structure of this molecule. So if I'm asking about the case of chlorine, it will be forming single bond, right? Cl, single bond. Then what about the case of oxygen? O double bond O, right? O double bond O. Then in the case of hydrogen, again, single bond. Then what about the case of F2? This is again single bond, right? So we have already studied in the case of a single bond, this is the single sigma bond, right? Then if you're discussing about the case of a double bond, one is sigma bond and the other one is pi bond. Then what about the case of triple bond? One is sigma bond and the two are pi bonds. So this is very important in terms of the double bond, single bond and triple bond, especially for the carbon compounds. So option B is the correct answer, oxygen. In the case of oxygen molecule, this is sigma bond, this is pi bond. Yes. That's all about from my side for today. We have already completed the chemical bonding chapter. We have already completed all the important topics from the chemical bonding chapter. And here we have already discussed around 15 or 16 questions from the chemical bonding chapter. I hope you guys enjoyed the session. And there is a general reminder about the SCORE examination. So as we already know, in the case of SCORE examination, Sri Chaitanya Academy is providing an opportunity to attend the national level scholarship examination, which is applicable for the students from grade 3 to 12. So exam will be conducting on September 28 as well as October 12. So before September 26, we need to register for the examination. The link will be provided in the description. You need to register for the examination before September 26. I hope that you have already registered for the examination. If anyone missed for the examination, just register now. So that's all about from my side for today. So thank you so much all of you. If you guys enjoyed the session, hit the like button, share this session to your friends as well as your family, and subscribe our channel. If you want to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. There you will be getting all the session PDF after all the classes. So thank you so much all of you. See you in the next class. Bye bye.